Hey guys, Mrs. B here. So this is our lesson for Wednesday, March 25th. Okay, and we're going to talk about identifying linear and exponential regression in tables. So far you've looked at linear and exponential regression equations, and we're able to type them in our calculator into GeoGebra to get the equation. Now we're actually going to look at tables with numbers in them, like these, and try to determine whether or not it's a linear or exponential function just by looking at the numbers. So just to recap quick, okay, here are my equations for both linear and exponential. And just to review, okay, in my linear, m represents my slope. Okay, and this is often called the rate. While b represents the y-intercept. Okay, where it crosses the x-axis, or sometimes we call this the initial value. The starting point, where it starts on the graph. Okay? When we look at the exponential equation, a represents my y-intercept, or the initial value, while b represents my slope, or my rate. Okay, I know that we have overlapping letters here. I know b means two different things when we're looking at linear versus exponential, but you guys have to memorize this, okay? The equations for a linear and exponential function and what those letters mean in those equations. Okay, the major difference, okay, what you should notice is that we have a slope and an intercept and an intercept in both of them. The major difference is the slopes. Okay, in a second we're going to look at some tables and we're going to look at the slope of both tables. In a linear function, the slope will be either increasing through addition or decreasing through subtraction. In an exponential function, the slope is either going to be increasing by multiplication or decreasing by division. Okay, this is the major piece here. The major difference, besides obviously the look of the equation, the major difference is how the slopes are increasing or decreasing. So linear function is addition or subtraction. Exponential functions are multiplication and division. And of course, the last major difference always is that linear functions are straight, while exponential functions have a curved line. Okay? Alright, let's go on and look at some examples. So I have two tables here, and the goal is we're going to try to determine whether each table is linear or exponential just by looking at the numbers. So let's start off. Okay, let's start with table 1. The first step, okay, to looking at these tables is we're going to find the slope or the rate. Okay, and we're going to do this by looking at the y values. So I'm looking at just my y values, and I'm trying to find a pattern in my y values. Okay, so I go to 5 to 10. Well, 5 times 2 is 10. 5 plus 5 is also 10. Let's take another look. 10 to 20. Okay, 10 times 2 is 20. 20 times 2 is 40, and 40 times 2 is 80. So the pattern that you see is that we're multiplying each of these numbers by 2. So times 2 times 2. And we just talked about how the major difference between linear and exponential is either adding and subtracting versus multiplying and dividing. Well, we just found the rate, right? The rate is times 2. So we know that it has to be an exponential function because we're multiplying by 2. So we know this is an exponential function. Once we know it's an exponential function, we've determined that we're going to write the formula for an exponential function, or the equation. Okay, that's my general equation. I need to fill in the a and the b with numbers. So, step 2. Okay, we're going to look for, first of all, we know our rate. Okay, our rate now, or our b, remember this here stands for our rate, or our slope. Okay, we know b equals We're multiplying by 2. So b equals 2. So we can fill that part in. Now I need to find my a, or my y-intercept. So step 2, okay, to find the y-intercept, we're going to look for where x is 0. Okay, when x is 0, what does y equal to? Well, I'm going to look at my table again. Here's where x is 0, and my y is equal to 5. So my y is actually equal to 5. So that's my initial value. That is the y-intercept. So here is my equation, my exponential equation. Okay? Table 2. I'm going to do the same steps. I'm going to start off. I'm going to try to find the slope. I'm looking at the y values only right now. Okay? So my y values, I'm looking for a pattern. What is the pattern here? 8 to 11, 11 to 14, 14 to 17, 17 to 20. It looks like we're adding by 3. So remember, if we're adding by 3, we know that addition is linear. Okay, addition or subtraction is linear. So we can say now safely excuse me, that this is a linear equation. So I'm going to write down my formula for a linear line, or my equation for a linear line. So I found my slope already. That plus 3, the pattern, okay, is your rate or your slope. So I can fill that piece in. We know it's plus 3. Now I need to find my y-intercept. Okay, remember, y-intercept, we look for where x equals 0. What does y equal? Here's x equals 0. At x equals 0, my y equals 8. So my b, or my y-intercept, is 8. Here's my equation for my linear line. Okay, so we're really just determining the pattern here in both of these tables. Table 1 we had times 2, and table 2 we had plus 3. Because we know it was times 2, it was exponential, it's multiplication. For table 2 with the plus, we know it was linear, because linear equations have addition and subtraction. Alright, examples 3 and 4. Okay, same thing. I'm going to do this a little bit quicker. I'm looking at the table. Remember, here's my x, here's my y. Same thing. Okay, h of x is the same thing as y. So I'm looking at my y values to start, and I'm looking for a pattern. 2 to 6, 2 to 18, 18 to 54. Well, 2 times 3 is 6. Does that work for the rest? 6 times 3 is 18. Yep, 18 times... Okay, so we found our pattern. Our pattern is multiplying by 3. So because it's multiplication, we know it's an exponential equation. Okay, since it's an exponential equation, I'm going to write down my formula, my equation for exponential function. So, what is the y-intercept? Remember, the y-intercept, we look for where x equals 0. Here's x equals 0, so my y-intercept is 6. So y-intercept, here's my y-intercept. Okay, a equals 6. My rate of change, which is my b for this equation, is going to be what I already found. The pattern, okay, is multiplying by 3. So we're going to write the function equation. So y equals, I'm just filling in, a is 6 times b is 3 to the x power. Y equals 6 times 3 to the x power. And part E, find h of 4. Well, does everybody remember? Remember when I wrote f of x, right? Anything inside the parentheses is always x. So we know that this 4 is an x. Well, we want to know, when x is 4, what is y equal to? So we know that x is 4, what is y? So here's how simple it is. I just take my equation I wrote. I wrote 6 times 3 to the x power. And I substitute x equals 4 right here. So now I have 6 times 3 to the 4th power. You can type it into GeoGebra, and when you type it into GeoGebra, you get 486. So when x is 4, y is 486. Number 4. Again, I'm going to look for a pattern. Okay, what type of function is it? I'm looking for a pattern. I'm looking at my y values. So 24 to 20, minus 4, minus 4, minus 4, minus 4. So I'm subtracting by 4. So if I'm adding or subtracting, I know that's a linear function. Okay? That's also my rate. I already know my rate. Here's my formula, y equals mx plus b. My m is my rate. So my rate of change is going to be minus 4. Now I have to find the y-intercept, or the b value. So my b is going to equal wherever x is 0. When I look at the x, when I look at my numbers here, I don't see x equals 0. But think about it. If I continued this table on, wouldn't 0 be somewhere over here before 1? Well, if the pattern is minus 4, let's go the opposite way. Let's add 4 to the opposite way. 24 plus 4 would be 28. So when x is 0, my y value is 28. So here's your equation. Y equals negative 4x plus 28. And the last piece to this problem is find b of negative 2. Remember, inside the parentheses, that's my x value. So we want to know what is the y value when x is negative 2. Okay? Real simple. You take your equation you just wrote, and you're going to substitute for x. Okay, so I have negative 4 times my x value is negative 2 from here, plus 28. Type it into GeoGebra, you get 36. So we know that my y value is 36 when x is negative 2. Okay, last set of problems. These are a little bit easier. Okay, practice creating a table of values for a linear and exponential function. So, all we really have to do is type this into GeoGebra and take a look at the graph. So I have y equals 2x plus 3. Y equals 2x plus 3. Enter. Oops. Let's try that again. Y equals 2x plus 3. Enter. Okay, here's my graph. Now I just look at the points that I need to fill in. If I go back, okay, when x is 0, what is y? Well, let's look. When x is 0, my y value is 3. Right, there it is. So I go back and I fill it in. And that, when x is 1, what is y? Well, when x is 1, I go up, y is 5. Oops. When x is 2, y is 7. And finally, like if you realize, you could take it from the graph, but if you look at the pattern, we're increasing each time by 2, right? Plus 2. So 7 plus 2, you should get 9. Right? And of course, if I fill it into my table, I have 0, 3, 1, 5, 2, 7, and 3, 9. A nice, straight, linear line. Okay, notice, plus 2, here's my rate, my slope. It was right there the entire time. So if you knew that and you knew 0, 3, you could just add 2 to every number in the y column. And the last one, let's try to do this one without GeoGebra. Of course, you can type this equation into GeoGebra and just fill in the table, but there is another way we can do it without GeoGebra. Okay? So notice on the last one, our starting value was 3, right? And then we added by 2. For an exponential function, our starting value is going to be on the outside. Okay, so we're starting with 3, and we are multiplying by 2. So 3 times 2 is going to give me 6. Times 6 times 2 is going to give me 12. 12 times 2 is going to give me 24. Now I can fill it in. That was a lot easier than typing it into GeoGebra. 0, 3, 1, 6, 2, 12, 3, 24. If you notice, it starts to make a nice curved approach to that line. Alright, that's it for today's lesson, guys. Once again, please complete the assignment. It's 1 question. Okay, 1 or 2 questions, I forget. Either way, complete the assignment, do it in a notebook, take a picture, and you can email or text it to me. Have a great day, guys. Miss you. Bye.